It is January 2026 and the landscape of real-time object detection has just shifted again. Just when we get comfortable with YOLO 11, the Ultralytics has dropped YOLO 26. But this isn't a slight bump in accuracy. We are seeing a fundamental change in how model operates. We are talking about a model built from the ground up for the edge, running up to 43% faster on CPUs compared to its predecessor. If you ever struggled with the non-maximum suppression bottlenecks or deploying on the edge devices, this release is for you. Today, we are breaking down the architecture of YOLO 26, the new MuSGD optimizer inspired by LLMs, and whether you should upgrade your production pipeline today. The headline feature here is simplicity. YOLO 26 is a native end-to-end model. For years, object detection relied on non-maximum suppression or NMS to filter out the duplicate bounding boxes. It was a necessary evil that aided latency and complexity during deployment. YOLO 26 removes NMS entirely. It produces the predictions directly. This reduces the inference latency and making export to the formats like TensorRT or Yonex much more robust because you don't need that extra post-processing step. But the most fascinating change is how it learns. YOLO 26 introduces MuSGD optimizer. This is a hybrid of SGD and beyond, an optimizer originally designed for training large language models like Moonshot's Kimi K2. By adopting the optimization techniques from the LLM world into computer vision, YOLO 26 achieves more stable training and faster convergence. They have also removed the distribution focal loss module. While DLF was great for accuracy, it was a pain for hardware compatibility. Removing it streamlines the model deployment significantly for edge devices. Let's talk numbers. Because of these architectural strippings, the speed gains are massive, especially on CPUs. The nano variant of YOLO 26 goes up to 43% faster than the YOLO 11 Nano. If you are deploying on Raspberry Pis, mobile phones or non-GPU servers, this is a game changer. In terms of accuracy, it holds its ground. YOLO 26 Nano achieves a COCO map of 40.9 while extra large variants hits 57.5. It effectively takes a tiny fraction of theoretical precision for a massive gain in real-world speed and deployability. And it's just not for the bounding boxes. YOLO 26 family covers a full spectrum: instance segmentation, post estimation, classification, oriented object detection for the things like aerial imagery. Using YOLO 26 is as standard as ever with the Ultralytics package. You just import the YOLO, load YOLO 26 weight of your choice, and you are running. There is also a new feature called YOLO26 for open vocabulary segmentation. This allows you to detect the object that weren't in your training set by using the text prompts, bridging the gap between the standard YOLO and the foundation models like Segment Anything model. YOLO 26 signals a maturity in the field. We aren't just chasing the higher MAP numbers on the leaderboard anymore. We are chasing efficiency, portability, convergence with the LLM training stability. If you are building for the edge in 2026, this is likely your new default. I have linked the paper and the docs in the description below. Drop a comment if you want a dedicated tutorial on fine-tuning YOLO 26 on a custom dataset. If you are interested in what is happening in the LLM space, please check my video on BLJPA. Thanks for watching.